So let's now dig into microservices architecture now. Now you have seen, right? So from monolithic to SOA, right? So we are actually coming in one step ahead, right? So from monolithic, everything, all the services together, tightly coupled. Then in microservice and SOA, we have seen it's more a component-wise architecture, right? So although SOA has, each component will be having services, right? But it is like a component-wise service, right? So it's not like a individual, independent service. So in a microservices architecture, we are actually moving towards, small services. Now, if you say, just define a microservices architecture, you may get, if you search for 20, pages, you may get 20 different definitions. But to simplify it, you can say microservices is a very self-contained process that provides a unique business capability. It's not necessarily like, service has to be very micro, okay, but it has to provide a unique business capability, and it should be, you should be able to deploy, develop, deploy, and test that service independently without any dependency. Okay, so it you may have, multiple features, clubbed together in a service, if that makes sense. It's not like, it should do only one thing. Only thing, when you design a microservice, you should take care your service should have a unique business capability. Okay, you can always club multiple, features or functionality together, but the business capability should be same, single. Like, order processing, for example, right? So for order processing, you may have a couple of things, which you don't want to, separate. So you can always, club all those features together in order processing service. So a important differentiating factor, if you see, SOA architecture, services may share, DBs, databases, right? Your persistence storage. But in a typical microservices, kind of architecture, the microservice, will not share database with other service. Service 1 should have its own DB, service 2 should have its own DB, and service 3 should have their own database. Okay, so that, for data related stuff, they should not depend on other services. So they should always, have their own database. That means they are self-sufficient. So when you implement it, when you test it, when you deploy it, you really don't need to, depend on others. Yeah, obviously, to achieve a complete business functionality, you may need service 1 and service 2 to work together, or service 1 and service 3 to work together. But you should be also able to, test and deploy service 1 independently. Like, there should not be any dependency when you deploy it. So just, take that piece, develop it, and deploy it in a container, consume it, and whenever you want to, dispose it, you should be able to dispose it. The dependency is like, suppose, for some functionality, they needs this particular service tree, right? And it has a single database, DB3, right? Now you are telling, okay, service tree is down. Now how service 1 and service 2 will give the functionality, right? Thing is that when you when you deploy these services, right? So you may deploy those services in containers. There will be some common entity which will monitor those containers, like, the service is up or not. If any container, any service is going down, you should be you should be able to spawn one more service in a different container. That's where the Kubernetes comes into picture, right? So they will help you to orchestrate your services. It's not like you will run a service only in one container, right? So in a real environment, right? So real, when you deploy in your production, obviously you will have replicas. So maybe first replica is down, you you can take a call, right? So you will be having your service registry, right? So service registry will be keep on, pulling those informations, which service is up, which service is down. Okay, yeah, this service is down, just they get a message, Kubernetes will again spawn one more service, right? Yeah, so there are risks, but we have options to mitigate the risk here. Okay. So yeah, so next thing is these services are there, right? So they need to now there is no enterprise bus kind of concept in microservices. If you see SOA, the backbone is enterprise service bus. Now suppose service one wants to talk to service two, right? So how it will actually talk to service two or service three, basically, right? So service to service communication happens in a two-way, right? So one is like regular, API call, REST-based call, or it can be via a messaging queue or like message broker. You might be heard about like RabbitMQ, Kafka, right? So those kind of things will come into picture. I will talk about it, all those things, but yeah, in a nutshell again, remember like service to service communication happens via those two channels. One is for synchronous service, that is like API calls, and asynchronous service, it will be via some message queues. Okay, so synchronous means like you are sending a service and you will get the response immediately, the way we have seen so far, right? All the REST calls. Sync means you are sending a request to a common again channel or broker or server, like Kafka server or MQTT kind of broker, right? So the broker will actually send a message to the correct recipients. Okay, so you may not get response there, immediate response. Now suppose broker is sending a message to a client, but client is that point of time client is offline. That can happen in IoT kind of environment. Suppose you have different sensors, a smart home basically, right? So you will be having different hardwares, right? So and you are controlling everything via a centralized broker. Now suppose from your mobile phone, right? So you want to turn on your light, switch on your light. Okay, use the how the broker will know that which light to switch on, right? There will be many lights connected in your home, right? So maybe one light in the hall, one light in the bedroom, right? One light in the bathroom, kitchen, so many lights. Now how this communication happens is actually a publish and subscribe model, pub sub model. Okay, so each component or each hardware in your smart home can register to the client. Okay, they can actually publish messages like, okay, I am the hall light in a subscribe topic. I'll explain in examples in coming this thing. So just understand the concept, like I'm telling to a broker I am hall light, so it will send a message. Now the mobile app, right, that is another entity, another client, so he doesn't know like IP and all those things. So this communication doesn't happen with IP address and port. So far whatever communication we have seen, right, the API based communication, right, REST based communication, it happens via IP and port. So you know your destination basically, right? But in async, actually you don't know the IP and port of your destination. You only publish some messages to a centralized broker, like I want information from this, and the centralized broker knows what are the channels or what are the clients subscribe to that, and it will send a message to that. That's all. So all the communication happen via a centralized stuff, or it is in async in nature. So you may not get depending on your implementation, you may not get immediate response. So in MQTT protocol, yeah, they have some quality of service kind of stuff, like it's a guarantee, whether you want guaranteed delivery or you just fire and forget kind of delivery. But that will take care of all the your communication basically. So you send it and then forget. So I'm publishing, I'm hall light, that's all. Now from the phone, I know like, okay, hall light is on, so I can switch it off. Using again is sending a message to the broker. So broker will take care, like, how to switch on, how to switch off, like that. But I really don't know, like, the IP and where exactly, from the mobile app will not know where exactly those devices are, deployed and how it is connected and all. But sync communication, it is a direct communication with your IP and the port. Okay. So yeah, see, in a microservices architecture, right, you can see, all different microservices, can have different tech stack, as I was telling you, like, order service may be, developed in .NET, inventory service can be developed in Java, and maybe, gift card in PHP. So there is no limit here.